Think, Learn, Innovate.
Hi everyone. In today's tutorial class, we'll find out the pulse transfer function of a digital control system. Few of my students are having problem solving this kind of problem, so I have taken a problem here. Find the pulse transfer function of the state equation given below, and that state equation is given here, as well as the and output equation. So to solve this kind of problem, actually what you have to do is you have to write down the formula first. The formula for pulse transfer function is given here. So I will say f of z, because it's a discrete time system, so the function will be zi minus of g inverse h plus I get d. Actually, I've taken d to be 0. The problem given that d is 0, so this is 0. So what I get is f z equal to c zi minus g inverse h. So first we'll find out zi minus g, and that's its z, and I is a is identity matrix minus g, and g is this one, this matrix. So 0 1 minus 0.16 and minus 1. What we get from here is we get z and minus 1. So 0 minus 0, it becomes 0.16, and I get here z plus 1. So till here we have got zi minus g. So what we'll do next is we'll find out the inverse of that function. So we'll say zi minus g inverse gives me z, here is minus 1, 0.16, z plus 1. I have to find out the inverse matrix of this one. Now the inverse matrix of this one is quite a bit easy. First what we'll do, we'll change the one, we'll say z plus 1. This will be your z, and I multiply with minus sign, minus 0.16, and I have to divide it by the over z plus 1, that is determinant of this one. I have to plus 0.16. Really good. So if we take this equation, so overall I can write down this equation in this bigger form of matrix, that is z plus 1 divided by z square plus z plus 0.16. Very good. And here I get 1 divided by z square plus z plus 0.16. In here what I get is minus 0. And this one is your minus 0.16 divided by z square plus z plus 0.16. And here what I get, z divided by z square plus z plus 0.16. So I got this inverse matrix here. Now what we have to do is we have to find out the z matrix, that is c zi minus g inverse into h, and that is nothing else. C is what? 1 1 is given down there, and you got this huge matrix here, that is z plus 1 divided by z square plus z plus 0.16. You got here 1 divided by z square plus z plus 0.16. And here we got minus 0.16 divided by z square plus z plus 0.16, and here you get z divided by z square plus z plus 0.16, and in here you have to multiply with your h, and your h is 1 1. So first of all, I will multiply this one with this matrix. So what I get here is 1 and 1, and I'll multiply this one. So what I get here, first of all, I multiply this one with 1 and this one with 1. So we get z plus 1 divided by z square plus z plus 0.6. And here I multiply and I get what? Z minus 0.16 divided by z square plus z plus 0.16. So I got this equation. So after this, if we multiply this one, what I get? Z plus 2, and this one with this one, so z plus 2 divided by z square plus z plus 0.16, and I get plus z minus 0.16 divided by z square plus z plus 0.16. So if I add these two, actually, what I get? 2z, and if I take this one out, I get 1.84. So if I go to the next page, and so I can write down here fz is equal to c zi minus g inverse h is equal to what we get here, 2z. So if I go back to my previous page, actually, we got that z plus, so we get 2z plus 1 divided by 2z plus, sorry, 1.84 divided by z square plus z plus 0.16. So my pulse transfer function is fz equal to 2z plus 1.84 divided by z square plus z plus 0.16. Thank you all for watching my video, and I will bring like lots of this kind of problem here. It's all free. You can come and you can watch it. If you like it, you can subscribe, and see you later. Bye.